Okay, differential equation. First of all, we'll be learning about first order. Basically, first order linear differential equation is just an equation with x and y and derivative of y, which is just dy dx. Okay? And then everything is linear. So you see, we don't have square. It's just power 1. Square would be our second order. Okay? So I'll talk about linear first. So a simple example of a first order linear differential equation would be just x dy dx plus 2xy equals to 3x. Something like this, okay? Equation of x, y, and derivative of y. That's all. And to solve this, let me give you an example. Okay, let's say I have this question. Okay, to solve it, we need to get the coefficient of dy dx become 1 first. So I divide the whole thing by x. Okay, so dy dx plus 1 over xy equals to ex over x. This is the first thing. Second, we get this part, the coefficient of the y. Get the coefficient of y. Okay, because we need to find integrating factor. Okay, integrating factor is something like this: e px dx. Okay, integrating factor equals to e power integrating of px dx, and px is just the coefficient of y. Okay, in this case it's 1 over x, so is equals to e integrate 1 over x dx, which is just e ln x, which is just x. Okay, now with the integrating factor, what are we gonna do with it? We'll multiply the whole equation with this factor. So dy dx plus 1 of xy equals to ex over x. Multiply the whole thing by the integrating factor, which is equals to x. So I get x dy dx plus y equals to ex. Okay, now this is the interesting thing. Okay, when we multiply the whole thing with the integrating factor, focus on this part. Okay, this part is actually equals to d over dx xy. Okay, when you differentiate xy, you get this whole thing. Okay, equals to ex. Okay, so for solving first order, basically we're multiplying the whole equation with something so that we could convert the whole thing into a differentiating of another formula. So with this thing, we can xy equals to integrate ex, right? When we differentiate xy, we get ex. Then when we integrate ex, we get xy. So xy equals to ex, and that's your answer, or plus c. Okay. What about another example? I got this. Okay. Same thing. Dy dx, because this time the coefficient is already 1, so okay, plus 2 tan x y equals to sin x. Okay, so coefficient is 2x, 2 tan x, px equals to 2 tan x. Okay, so e integrate px dx equals to e. I'll split this into two parts. Okay, integrating 2 tan x dx equals to 2 integrate sin x over cos x dx. Right? And then, if you don't know, if we differentiate ln cos x, okay, we will get negative sin x over cos x. Okay, so similarly, if we integrate negative sin x over cos x, we get ln cos x. Okay, so to get the negative here, I just use negative 2 ln negative sin x cos x dx. Okay, so I can substitute the whole thing, so equals to negative 2 ln cos x. Okay, and with this thing I can put it to power e, right? E, so I get this, and we know that these two cancels out, so I get cos negative 2x, which is just 1 over cos square x. This is my integrating factor. Okay, now let's try putting everything in. I multiply this whole equation by 1 over cos square x. Okay, so 1 over cos square x dy dx plus 2 tan x over cos square x y equals to sin x over cos square x. Okay, now check this out. Again, if I don't use cos square x, I can also use sec square x, secant square x. Okay, now this is the interesting part. If I differentiate secant square x y, I get, okay, let's just use the product rule. I differentiate y first, so dy dx, and then I differentiate sec square x, which is just 2 sec x, and then differentiating secant x, we get sec x tan x, so it's sec square x dy dx plus 2 sec square x tan x y. See the familiarity? Yeah. So again, I can convert this whole thing into d over dx sec square x y, and it's equals to sec x tan x. Okay, and then continuing, move the differentiating into a integrating sec x tan x dx. Okay, and when we integrate sec x tan x, what do we get? We get sec x plus c. Okay, sec square xy equals to sec x plus c. Now they gave us some conditions. Y equals to 1, x equals to pi over 3. Okay, so you substitute your values in, and then you get your c, and then you have your final answer. So for the whole solving first order differential equation, it's just arranging it into dy with coefficient of 1, and then y, okay, with their coefficient, we call it as px, and then equals to a function of x, okay, fx. And then you get your integrating factor, which is just equals to e to power to integrating px dx. Usually your answer will have lns, so everything will cancel out. If it doesn't, then it's okay, don't worry, just continue doing it. Okay, and then when you multiply the whole equation with your integrating factor, you can convert your whole left side into a differentiating equation. Okay, so you can move it to the other side into an integrating, and then you can solve your equation. That's for first order.